Okay, guys, let's go ahead and check on this one real quick. Basically, it's going to be a mixture of stuff. Go through it slowly. Ooh, this one's pretty easy, actually. Okay, so in case you forgot how to do this one, just graph it on the calculator. That's it. I want you to remember this one. It was going to be x minus h, but here it's a negative 1, and then plus 2. I want to say it's that one. Let's double check. I'm going to turn the calculator. I'm actually going to not minimize this, just move to the side. Calculator here, turn on, new document, do not save it. Graph, 2 parentheses, x plus 1 squared plus 2. So let's look at that one. Any way you want to do it. I think I'll hit a graph, or go analyze graph, and I'll go find the minimum. Negative 1, 2. Given the quadratic model, what would be the best way of x to be negative? Oh, x to be 9. How far is it this way? 1 here. 3 here. X to be 9 would be here. I would say more than 10. So no. How far is that? 2? You know what? I don't know what you're going to think. I'm sorry for wasting your time. I want you to just do it real quick. Put all these things. Quadratic regression. And then go add the graph. Type in Control T to get the 9. X to be 9. Then find it. So basically, kind of turn it on. Do not save it. This in spreadsheets. I want to type in these numbers. Negative 1, 1, 2, 5, over here, 34, 10, 4, 10, come on here, menu, 416, quadratic regression, B, control this, and to enter. I don't even care about this. I care when x is 9, so I want to come out here and add page. I'm going to add a graph. See, it's on 2. If I press up, it's the one I had right there. I'm going to go Control T and go down here to where x is 9. 74. Okay. Just in case you didn't see that, what I did here, put the numbers in here. Then we go to menu. 416 quadratic regression. Got that. Then I added a page. How you add a page? That's how you add a page, okay? So I'm going to add a third page here. Control document. You see right there, it's the first page. You add a graph. See, it's on 2. If I press up, it's adding that one from the other one I did. Now, several ways. I did it right now. I know that's the minimum. I know it goes down. So in here to analyze graph, I found the minimum from here to here. Oh, I didn't. I actually found it when x was 9, right? So yeah, we'll go to Control T. There it is. I'm going to Control T to get rid of it. What you can do, guys, is go to menu, trace, graph trace, and just type in when x is 9. See, x equals to 9, and see, there it is. Okay. So this one's asking 2x plus 1 side and a square, that's perimeter. So a square here is here. Remember, square is the same thing all the way around, and it's saying that this side is 2x plus 1, and the area is that. So remember, to get the area of a square, it's equal to side squared, and that's S, basically your side. So you're going to have area is equal to 2x plus 1 squared. We know what area is. So 121 is equal to 2x plus 1 squared. I don't know what to say in this one. See one variable, see equal signs, and solve it, yeah? Because I'm trying to find my x. I can't tell you the area or the perimeter until I find my x. Add a document, no. I'm going to go to calculator. menu 3, 1. I'm going to go to 121 is equal to the parentheses of 2x plus 1, all that squared, and I'm going to put comma x, enter. So x is equal to 5. Sneaky. You want to go for that one, but that's wrong. Perimeter. So now we know here that x is equal to 5. The perimeter now. And this one side is a square. Remember, the square is like this. This side is 2x plus 1, but now we know x to be 5. So you basically have 2 times 5 plus 1, which is 11. Now 11 is one side. To get the perimeter, it's going to be 4 times the sides. Perimeter is equal to 4 times 11, which is 44. We're right, they're wrong. A, B, C, D, E. Which of these is equivalent to this one? Okay, and we forget, go back to the things, the very beginning of the, I think I have a benchmark here. I don't, sorry about that, okay. So the rules are there. Let me go get you one about, hold on. Okay, so here I find you the STAAR release 2017. Here's your reference material. So look at the one that we're looking at right now. It's having like a power, it's called a power to a power. And that's actually what it's called. Power of a power. You see this? Power to a power. So you basically multiply m and n. So I'm going to have x to a negative 3 times a negative 2. Then y with a squared times a negative 2. Top gives me x is 6. Bottom gives me x to negative 4. This is wrong right here. This is not right. So you don't like that. And regarding this part, this is kind of like all over 1. You see, it's there. I don't write it unless I need it. So now I need it, so I put it there. This one I'm going to throw the denominator. So we're going to have x to the 6, and now I have y to the positive 4. A, B, C, D, E. X to the 6, y to the 4th. Oh, sorry, x to the 6 over y to the 4th. And did I do something wrong? Negative times positive, negative, which goes to the bottom. Negative times negative is a positive, stays on top. Yeah, we're right, they're wrong, okay? This is just algebra. Basically, that's it. Oh, come on, pen. Plug in here for h. G to be that, and then we'll find v squared, okay? V0 means like the beginning, the initial. VO means like the initial, very beginning, 0 time. Initial, beginning, the very beginning of time. So we basically have right here, 80, okay, I guess I should, sorry guys, I haven't read this one in over a year, but that's how fast you should be able to do them. You just, okay, plug in for and solve for V, that's it. In physics, the following formula is used to find the height of an object given the initial velocity. So the height, this is gravitational pull, 9.8 meters second squared. This is wrong. And then there. Okay, so we're going to come out here and plug the values in there. 82.45 is equal to v squared over 2 times 9.8. Honestly, just and solve it. That's it. Menu 3.1, 82.45 is equal to, we're going to go with v squared divided by 2 times 9.8, comma, B. About 40.1, okay, 40.2-ish. A. What is the solution for this one? So you should know how to do these already. Honestly, I showed you how to graph it. I showed you how to use, I guess, substitution, elimination. Save yourself the brain power or the headaches. Just do this. 3, 2. Okay, 2 equations and type them in there. X minus 5y equals 2. 2x equals 10y plus 4. Enter. Okay, remember when it gives you that stuff right there? That's infinity. Okay? Weird. Or that's infinite solutions. Now, basically what this is telling you, if you were to graph them, you would have a line and then another line on top of it. Means that they touch everywhere, infinite many times. What's the perimeter? If the perimeter of quadratic is 62, what is the value? Okay, so this one's hard but easy. It's hard because you got to do some work. Easy because it's easy work. It's like inconvenient. You got to basically understand what perimeter means. Perimeter means add them all up. So I'm going to go in order by all these things. I'm going to say there's an x squared, no other x squareds. Here I have 2x, 3x, 6x. Here I'll have, these cancel out. If you don't mind, gone. Plus 7 equals 62. And solve? And solve. Okay, so I have to write this equation. This one down fast. X squared plus 6x plus 7 is equal to 62. -3, 1. Okay, how did I know the ends off, guys? There's an equal sign, one variable. X squared plus 6x plus 7 equals 62. Now we do comma x, 5. What's the value of x? 5 is your answer. So where you see that, where you observe the mistake, this is a STAAR test question, is where it's at. Okay, so I would first distribute here and distribute here. When I do that, it gives me 4x squared. This right here gives me 2x. Oh yeah, 1x. Distribute here, and that gives me 12 divided by 4 negative 12 divided by 3 negative 4. Perfect. X. This times this gives me 18 divided by 3 negative 6. I like that. Now I want to collect like terms. You see this one and this one? Right there. Positive, negative, x, 4x, perfect. These two together give me a negative, perfect. Everything looks good. Just brought this down, perfect. Oh, these two do not add up to here. So there's a mistake. Step 4. On step 4 is a mistake. This is, everything's correct here, correct, correct. The mistake is here. Given the 4 points of the function, or could be linear. I gotta hurry up. Class is gonna start. Okay, so on this one, you need to use the calculator to help you out. Honestly, this is designed for calculator. This is a design question for calculator. So you come here, no, we're gonna go to listen spreadsheets, type in these numbers. Move it over a little bit. Or you can plot them, it's up to you. And you can see what it is. Here, negative 20, and then 320. Over here, negative 3, 1758. Over here, negative 12, 138. Over here, negative 6, 1002. You can kind of get a feel with this. What's this doing? The further left I am, the lower it is. The further right, the higher. Ooh, I don't know what this one is. This is ridiculous. Enter. Come over here. Okay, time I got it. Okay, so on this one real quick, it's asking what is it? It's asking if it's quadratic. It's asking if it's linear, quadratic, exponential. I'll tell you this much. It's neither of them. Okay. I kind of look at the calculator here, add them up as lists and add them as graphs, and so this is what you want to use. But to me, I didn't feel comfortable with it. So on this one real quick, I'm gonna control skip this one. Okay, we get rid of that stuff. So I want to check if it's linear. First, I want to check if it's linear. The way you do that is you go to menu, and you go, I guess, 4, menu, 4, 1, 3. I'm checking if it's linear, right? Here. B, control this. If it's linear, this should be r and r squared should be 1. They're not, okay? Not linear at all. I'm going to control escape, get rid of that. I'm going to go here, check if it's quadratic. I'm going to go to menu, 4, 1, and then 6, quadratic. Same thing here, we should have b and b squared to be 1, same as it is. But r squared, man, is so close to being 1. This is like so close to being 1. So no. But I'm going to say that's the closest one. And I'm going to check exponential. 4, 1, exponential. And B, control here. And I get that one. The R's not even close. Hold time on. So the one I think it's the closest to is quadratic. Okay, that's just the way it goes. Okay, so f of x is equal to negative 3x minus 11. So you should know how to do this stuff, right? You can graph them. Sorry guys, hold on. So f of x, you can graph them in the calculator, okay? I can do it by hand real fast. Maybe I should use the calculator because it's going so slow. Negative 3, okay, it goes to a negative 11. And has a slope of a negative 3. Pretty steep right there. That's f of x. G of x is a positive 4. Same slope, because they both have a negative 3. So they don't touch it and get closer. Sparse part 3 pink. Then we're finishing at g of x in terms of f(x). G of x is, okay, assix f of x now. Is g of x is below. Oh, this is g of x. G of x is below f of x. No, g of x is above. F of x is below. G of x is below f of x. G of x is below. No. G of x and f of x have the same slope? Yes, they do. Same slope, negative 3 and negative 3. B is the answer.